Hi, I'm Paul Battaglia, and this is Section 4.4. Students come into Section 4.4 having a little bit of knowledge about some basic integration rules, and now they've seen area in either Section 4.2 and/or Section 4.3. So it's time to take that one step further and develop the connection between the definite integral and the fundamental theorem of calculus. And that's exactly our essential question. We want students to be able to answer, what is the fundamental theorem of calculus? So we start off with a couple of good examples in the textbook, just running them through how to work with the fundamental theorem, how we arrive at it from our area connection. But the next thing we do is we go into the mean value theorem for integrals. And in this case, it's important that students start to make the distinction between the average value of something and the average rate of change. The average rate of change refers to a derivative concept, something they've heard a couple chapters ago. Now we're talking about the accumulation of change. And when students are asked to find that, it's important they know that's an integration concept. Now, the nice thing about the fundamental theorem of calculus is there's a lot to it. So there's a lot of time to do some things. And what I like to do is I actually like to have my students discover the second fundamental theorem. I don't like to say a word about what it is or how it works. I'd rather them try and discover it on their own. Because what I want them to see is there's something going on here. The notation looks funny right away to them. Why are you asking me to do the derivative of an integral? Will they recognize that they actually haven't, quote unquote, moved anywhere? If you integrate a function through the discovery and then go derive it, where did you arrive? Right back where you started. But this is an important thing to do. So take the time to do it. Even if it takes a large chunk of time on a certain class period, this is where pacing becomes very, very important. So speaking of the fundamental theorem, the second fundamental theorem, let's look at some common errors that students might make. Now that they've discovered what it is, I like to give them a little bit more of a challenging example to see if they can pick up on some very specific things. Most of the early examples, and certainly the ones that they've seen in the discovery, may only have an upper limit of integration that has a differentiable function. The lower limit might be a constant. So it doesn't pose too much of a problem. Now let's go to something like this. Let's take the integral with a lower limit of x squared and an upper limit of sine x of the square root of t squared plus 1 dt. Let's ask students to apply the second fundamental theorem and find the derivative of that expression. Here's what we're looking for. Let's start with this. The first thing they should be able to do is know that they have to plug that upper limit in for t. Now they have to recognize that they also need to plug that lower limit in and subtract them, as stated in the fundamental theorem. But in doing both of those things, did they remember to derive sine of x and multiply it by f of sine of x? Did they remember to also derive x squared and multiply it times f of x squared? So there's a lot there. And there's a lot of opportunities for you to address these things. You may actually find you need to go through another example very much like this to see if students can master a more complex problem. Now, the other thing that students do sometimes with the second fundamental theorem is they are so used to seeing an integral that they still want to write plus c at the end of their answer. Remember, with a definite integral, they got away from writing the plus c. So now they see the integral notation and they see their answer as an expression involving variables and terms. So they think the plus c still needs to be there, but it doesn't. So here are two other mistakes you also would like to look for. With the fundamental theorem itself, students actually sometimes forget to integrate. They want to do f of b minus f of a so quickly, they forget they have to integrate first before they can evaluate either of those limits. When they're doing average value calculations, again, they'll do f of b minus f of a and enact the fundamental theorem. But they'll forget, since we're trying to find average value, they haven't divided yet by the width of that interval, b minus a. So call attention to these mistakes if they come out. And don't be afraid to highlight them in class. Now, let's talk a little bit more about some conceptual things that students might face on your assessments or even on the AP exam. I'm going to look at a graph here, and I want to say that this is going to be the graph of the velocity of a particle. Let's suppose that that graph starts at 0, 0, edges itself up, comes back down, crosses the x-axis, goes underneath for a little bit, comes back to the x-axis. Now we've set the scene. That graph represents the velocity of a particle. And maybe you'll be asked to find the total distance that the particle has traveled. What we want to keep an eye on here is that negative area. We want students to understand that if we're trying to find the total distance of a particle's travels, absolute value might be necessary. Think of it this way. If I got in a car and I drove 100 feet forward, but then I had to back up 50 feet, did I not travel a total distance of 150 feet? Sure. Even though when I backed up, I was in negative velocity. See, they need to be mindful of this. Along the same lines, what if with that same situation, a student was asked to find when the particle was farthest to the right? Well, in a situation like this, there's a lot of things that students need to look at. We need to know where the particle started. We need to look at where it was when we got to that point, when it crossed the x-axis. How far now has it traveled? And what is its position after we include that negative area? See, these are all deep conceptual things that we need to expose our students to really further their understanding of the use of the fundamental theorem. Now lastly, we've talked about a lot, and there's a lot in the fundamental theorem section. So don't feel intimidated at all to try and cover this in one class period, even if, like me, you have larger class periods like 77 or 80 or 85 minutes. Feel free to take 2 or 3 days. It's so crucial that students understand this concept, because if they do, things after this will flow a lot easier for them. But if they don't, it might be very rocky. I hope these tips have helped, and I'm sure you'll find much success in section 4.4.